Good evening, my lovely 12th standard warriors. Time to battle it out with me, Shreyas, your physics master teacher at Vedantu, going live. The most awaited session by all of you. A 12th standard student studying for JEE or NEET can attend this session. Even if you're going to write this examination in 2021, you can still attend this session. So this is for all the students who have studied the chapter of magnetism. Hi Akshita, Jay Srinivas, hello Gautam, hello Surya, hello Rakesh, hello Kaviya, hello everyone. And if you guys are here, the only way I would know and others would know that you guys are present is when you chat and when you put some nice and lovely things in the chat box. So do not forget to keep chatting out there. But yes, when you're solving problems, don't chat. All right. Thank you guys so much. Hi Kaushik, hello Sai, hello student. Hi, Paparazzi is also here. Hello, Manisha. Hello, welcome aboard, everyone. So yes, a 2021 JEE student can also attend it. Just like I said, even a NEET student can attend it. So by the way, those of you who do not know me, I am Shreyas. And if you want to know more about me, you can definitely follow me on my Instagram handle. That's Shreyas_Vedantu. All right. So do that. And meanwhile, okay. So by the way, those of you who do not know what Menti is, let me tell you. See guys, Menti is nothing but an online quiz. Okay, Menti is a competitive game kind of a thing, and anybody can participate using the Menti code. The Menti code is in the pinned message in the YouTube chat box, like you can see right now. Get ready for the Menti battle. Join using the code 6513449. You need to go to www.mentee.com, and that's the only way you can participate. Okay, so time to get ready for the quiz night. Are you guys ready? If you guys are ready, please first of all smash the like button so that way I can get my energy. Come on guys, I cannot see the likes increasing. Come on, please put that up. Yes, hit the like button. So the Menti topic is going to be on magnetic sources, that is Biot-Savart's law, Ampere's law and all of that. Then you also have magnetic effects, that is force on charges and current carrying wires, and the properties of magnet and Earth's magnetism, like the magnetic dipole moment and bar magnets and Earth's magnetism, magnetic materials, all of that combined together. So get ready guys, it's time for the quiz night. So those of you who do not know what's the Menti quiz code, there it is, 6513449. I'll give you a tip. If you have a mobile and a laptop, on your mobile, maybe you can download the app or you can watch the YouTube lecture, and on the laptop screen, maybe where it is bigger, you can open the Menti quiz, because then you will see the questions in a big way. Make sure that you have two tabs or two windows or two devices, because only when you have two screens, either tabs or windows or two devices, only then you will be able to solve the questions properly, because on YouTube I'll be giving you instructions. You will be listening to the questions beforehand, even before the questions come up on the Menti quiz. And let me tell you guys, the delay between the YouTube video when I talk something and by the time it reaches you is around 10 to 15 seconds at least, but the questions might appear before. So that's why I'm going to tell the questions beforehand. So you need to pay attention to the audio, and remember, on the Menti screen your quizzes will appear, and the timing starts not as per YouTube but as per the Menti quiz. Keep that in mind. You will only get points when you answer correctly. If you answer wrong, you do not get points, but if you answer a little bit fast, you get slightly more points. Make sure you answer correctly than being at haste and trying to answer really fast and losing out those marks. So let's see who and all are there. I'm pretty sure you would have got your avatars by now. Whoa, the screen is flooded, man. We have the snow, the fish, we have detectives, we have unicorns, we have footballs, we have the bears, we have the strawberries, the ghost, dragons, lion, crown, footsteps, honeybee, volcano, and goat, and burger, and worried, and a laughing cat, and unicorns, and candy, and birthday cakes, and penguins, and trucks, and magical hat, and paper clips, and ghosts, and bananas, and God knows what. Great. So people have started identifying themselves. Very good, Shiva. If you have completed the exam yesterday, now you can prepare yourself for the next exam. By the way, 12th standard students, do you have any idea how many questions were asked in roughly every shift this year from this Menti quiz chapters that we are covering today? Any guesses? How many questions in each shift or in each paper of physics? You know, how many questions were there from these all chapters? The entire of magnetism, magnetic effects, magnetic sources, bar magnets, Earth's magnetism, and magnetic materials. There were not more than 50%, man. How can you have an entire paper on magnetism? No. There were 2 questions at least in every shift. Every shift had 2 questions. Some shifts had 3 questions. So you can imagine 3 questions is 12 marks guaranteed in your pocket. That's a big number, guys. Let's get going. I hope you guys are ready. Time to start the quiz in a minute. I'm going to start the quiz in a minute. Okay. Oh, thank you, Rajotanam, for reminding me for the weekly timetable. As soon as I'm done with the Menti quiz, I'll post up the weekly timetable for you guys. Okay. Also remember, tomorrow at 7:30, you have your favorite nurture series for the 11th standard juniors. So if you have your friends, your juniors, remember tomorrow, 11th standard Menti quiz. And by the end of the week, guys, we are starting the next chapter. Guess what the next chapter is for you guys? Pathfinder, 12th standard. We are starting with EMI, Faraday's law and Lenz's law, starting this week. So yes, show your excitement with the likes and hitting the subscribe button down there. Time to start the Menti quiz. Now, no, ray optics will come after that. Okay, George, don't worry. Ray optics will also be done, but after that. But hold on. First, let me complete entire of magnetism, EMI, AC, and then we'll come to ray optics, and then in the end, we'll go to modern physics. All right, let's get going. Now, the first question, I'm reading the question. Your attention should be on both the screens. Get set, go, guys. I'll post up the question in a bit, but I'm reading it out for you so that you have the advantage. Okay. So choose the correct sketch of the magnetic field lines of a circular current loop. Okay, there is a circular current loop. Which of the following diagrams is the best diagram which represents the field lines due to a circular loop carrying current? Pay attention to the dot and the cross, how the current is flowing. Do not post the answers in the chat box or else you will be timed out by the administrator. Time to get set, go. On your screen now, guys, all your attention should be on your screen. The timer would have started. Okay, choose the correct sketch of the magnetic field lines of a circular current carrying loop. The dot and the cross represents the current in the loop. Okay, it's a cross-sectional view. Please understand that. It's a cross-sectional view. Come on, my warriors, figure this out. It's not that difficult. I'm pretty sure you can get it. Just imagine a circular loop. I'm pretty sure you'll get it. How to solve the questions, Badri? You can solve it in the rough book somewhere and you have to mark the answer in the Menti quiz. Okay, and there we go. 41% Janta has answered it correctly. More than 50% got it wrong. Achha, let's see what the correct answer should be and why it should be the correct answer. See, guys, the thing is, if you first draw a circular loop, things will be very clear in 3D. So this is a circular loop and look at the current, okay, dot and cross. So let's say the current is flowing like this, for example. So when the current will come here, it will look like towards you, and when the current is going inside, it will look like cross. Okay, example. Now, if you hold your right hand curled fingers in the direction of current, the thumb will give you the direction of the field lines. Hold your curled fingers in the direction of current. You will see the thumb points upwards. That means the magnetic field will be like this. This is the magnetic field. So there is only one diagram which shows the correct representation, and I think that is option A. Okay, look at option C, guys. There is a cross and a dot. The only difference between A and C is that, you know, these dots and the crosses are different. Option B and D is not correct because we know the magnetic field lines due to a circular loop carrying current will look something like this. It's not this or this. You can see that. It has to go like that. You can see it goes like this, it goes like this, it goes like that. Yep. So this is the correct option, option A. I hope this is fine. Shall we go ahead? Okay. Now let me also show you how the leaderboard looks like. I'm not going to show the leaderboard in every question, just in the first and the second question. Then after every 5 questions, I'm pretty sure you're used to it by now, I'll show the leaderboard every 5 questions. Wow, 2 people were very quick. Sai Capto, oh nice name. Nitha was also as fast as Sai. Pushti, Bharat, Asmi, alias Manoj. How many names you have? Shreyas fan, I guess that T was a spelling mistake. Srivatsa, Rohit, Himanshu, kya IIT Bombay jayega? Bilkul jayega, Himanshu. 72. I don't know what that number stands for. Karthik, excellent day. Volcano is on the leaderboard. Don't worry, even if your name is not on the leaderboard, you need to keep trying. There are 20 questions. How many questions? 20. Do not lose hope. Things change drastically. If you have been attending my Menti quizzes previously, you know that things change, at the flick of a second. Okay, let's get going. Next question. Curie temperature is the temperature above which? Curie temperature is the temperature above which? Come on, question is up on your screen. Badri, how to solve questions at home? I'll probably respond to your comment if you post it up as a comment so that others can also benefit from it. So after the video ends, just put it up as a comment. I'll respond to your comment, Badri. Okay, come on, my warriors, figure this out. Curie temperature is the temperature above which, remember, you should have 2 screens open, and if you're joining in late, go to mentee.com. Only 1 question is over. Type it out, mentee.com. The link is also there in the pinned message of YouTube chat, and enter the code 65134449. That's the Menti code, 65134449. Do not post the answers in the chat box. All right, a lot of you have answered correctly. I'm really proud of you. I think you have revised the theory properly, guys. So Curie temperature is the temperature above which a ferromagnetic material becomes paramagnetic. So that's the critical temperature. Remember, diamagnetic is the worst material. Para somewhat aligns in the direction of external field. Ferro is like heavily magnetic. If you increase the temperature, the domains get broken. So at a temperature above the Curie temperature, understand the domains are destroyed. They're destroyed. And that's why once the domains are destroyed, it behaves like a paramagnetic material. Very good. So it is useful for all the exams where these chapters are there. So I'm not sure which all exams you can talk about. EMCET, sir, this CET. It's useful for all the exams as long as this chapter is there. All right. Let's get going. Ocha, what is the last option? What is it called? A ferromagnetic material becomes diamagnetic. That's not even correct. That's factually wrong. Okay. That temperature is not called anything because that never happens. All right. Okay. Let's get going. Come on, my warriors. And let's see the leaderboard. Wow, Shreyas fan, the frog is really fast. Pushti, the birdie, is on the 2nd position. Hardly any difference. Sai Capto 72, Himanshu, IIT Bombay jayega. Anurag Mohanty, Navi, Anju, it's me. Bharat, Asmi, alias Manoj, my god, 4 people, 5 people out there. So you can see a very close competition. Let's get going to the next question. Now, remember, initial questions are easy. The level of difficulty will increase. The timing of the question will also increase. Right now, all questions have 30 seconds. Slowly, the timing will also increase. Guys, if you are late, go to mentee.com. Enter the code, which is 65134449. Do not worry even if you are late. All right. For a paramagnetic material, the dependence of the magnetic susceptibility on the absolute temperature T is correctly given by, for a paramagnetic material, the dependence of magnetic susceptibility on the absolute temperature T is best given by which of the following relationships? Come on, 4 relationships are given, only one of them is correct. Think about it carefully and mark. You cannot change the answer, and if you answer wrong, you do not get points. If you answer correct, you get points. If you answer quickly, you get more points. But that does not mean you answer really quick, because you might make a mistake in haste. Come on, my warriors, figure this out. All right, come on. And guys, if you're finished doing the question, come on, go hit the like button. And if you are new to this channel, English exclusive channel for you guys, JEE English channel, go hit the subscribe button right now. Very good, Rajaram, if you're in the 10th place. And a lot of you got it correct. 50 people have got it correct. Excellent. Now let me tell you what is this law. This is called as Curie's law. This is called as, this is called as the Curie's law. Keep this in mind. So Curie's law states that the susceptibility is inversely proportional to T. This is for paramagnetic. Look at that, paramagnetic. But remember one thing, X is constant. This is for diamagnetic. I hope you remember this. So if this word was not para but it was dia, then option D would have been correct. And if it was ferromagnetic, remember it becomes para. It becomes para after critical temperature. So it is a constant upon T minus Tc for the ferromagnetic material above, Tc temperature. Before Tc, it is roughly constant. That's how it is. Is that clear? These are the laws. Remember this. For dia, it should be there in your notes. If you have attended my classes, I have given you one PDF. It's all there. I have explained in the class also. Please check that out. Alright? Let's get going. Badri, no bacha, I will not explain it faster. Sorry. I have to make sure that everybody understands. Please don't be in a haste. Sir, just tell the answers. That's not the correct attitude. You have to have the patience to know what the answers are. This is where, now Badri, you are only asking, right, how to solve problems. This is the exact mistake you are doing while solving problems. When you solve a question, if you are not analyzing what the other options are, if you are not understanding what the wrong method is, what the other things are, if you are not reading between the lines, that's the wrong thing you are doing. You need to analyze, spend time, quality time with the question. That's the way to solve the problem. I hope you get it. Yep. Never be in a hurry. A lot of people are in a hurry for no reason. Sir, next question, sir, next question, sir, next question. I don't know which bus you have to catch, man, which local train, where do you have to run? It's like I remember the time when I got out of the, Mumbai airport. I came from Seychelles, I remember. In Seychelles, it was all peaceful, it was all relaxed and everything. I came to Mumbai airport. I just got out of the airport and people are just running. I don't know why. What are you running for, man? What is the hurry? Like, catch the bus, man, catch the bus. People are just running. It's just there in all of us. Run for no reason. Cool down, calm. Okay, cool. Let's get going. Next question. What is surname? Sravani, my name is Shreyas. Okay, let's get going to the fourth question. In a diamagnetic material, which of the following option is correct? Relationships for relative permeability and susceptibility are given. Mu R and susceptibility are given. Only one option is correct. Figure that out. For diamagnetic. Come on, my warriors. Leaderboard will not be shown for every question. It will be shown after every 5 questions. Come on, come on. Thank you, crazy guy. All right. Come on, come on, come on. Think. For a diamagnetic material, only one option is correct. Mu R and susceptibility are given. Akshita, if you have some doubts which are outside of the topic, please put it up in the comment section after the video is over, or in my just previous video I'll answer to that, but I don't want to break the flow of the class. Alright, beautiful. 38% Janta have got it correctly. Lot of you got it wrong. Guys, it's a diamagnetic material. Dia is the worst material. So remember, I had given you the classification: dia, para and ferro. So if you talk about mu relative and susceptibility, okay, just remember one thing: relative permeability for diamagnetic material is less than 1. For para, it's more than 1, and for ferro, it's much more than 1. Similarly, remember, mu R is nothing but 1 plus susceptibility, or rather x is nothing but mu r minus 1. So if you use that also you will get it. So if relative permeability is less than 1, for diamagnetic susceptibility will be negative, this will be positive, and this will be heavily positive because it will be much more than 1. That's it. Yes. So this is the table which you should remember. Okay, dia is less than 1, relative permeability is less than 1, para it's slightly more than 1, ferro it's very large as compared to 1. Yep. So that's the answer, guys. I hope you guys got it. All right. Excelente. Let's get going to the next one. Okay, let's see. Question number 5 coming up on your screen. Other collab mentee session. I'm not sure what do you mean by other collab mentee. Acha, you mean like other teachers together? We'll plan it soon. Let the JEE mains and BitSat get over. Okay, then we'll get some breathing time. There is magnetic field produced and it is directed along y-axis. There is a magnet placed along the x-axis. Magnetic field is along y-axis, magnet is placed along x-axis. What is the direction of the torque acting on the magnet? Because of this, even if you are late, go to mentee.com, only 4 questions are over. Enter the code 65134449. Participate in the quiz. Do not participate in the chat box. This is the only way you can compete with others. Thank you, Varun. Glad it has helped you so much and you have become a hero. Thank you so much and see you live more often. Harsh, don't worry, bacha. Just relax and don't study anything which you don't know. Okay? Please just revise through formulas and sleep well and go with confidence. Full Josh you should go. All the best, Harsh. And I'll be seeing you tomorrow for the discussion for morning shift. After the session is over, see you guys at 1 o'clock also. All right. Lot of you have got it correctly. Beautiful. Excellent day. So what you need to do is that, see guys, formula. Torque is M cross B. You should know this. Okay. Where is M? Magnetic moment is along I cap. Where is magnetic field? Along J cap. So what is I cross J? I cross J is K cap. So this is X, this is Y, obviously this is Z. So hence it should be along Z axis. As simple as that. Very easy. Lalu Goshen. M cross B is the torque value. I cross J is K, which is the Z axis. Okay, cool. I hope you guys got it. Time to see. You can also use right hand rule if you want to, obviously. Time to see the leaderboard right now. Let's see. Anybody has changed, anybody new. Oh my god, somebody by my name only has come out here. Very good. Bharat, Asim, alias Manoj. 3 people are on the top. My fan. Then Naman was really fast. He's eating burgers. Akshay, Aki Pro, Menti Star. Yes, Akshay, you're a Menti Star. Cool, bro. Sai Capto, Anu 72, Rakesh Kamlia, my name only, my duplicate, Raja Raman R. Very good. Congratulations. Let's get going to the 6th question coming up on your screen. And the 6th question is, remember, there is a bar magnet. It's suspended in a uniform field in a position such that it experiences maximum torque. Thank you, Krituga. I love you too, bacha log. Yes, this is for NEET session to Rishikesh. Join in, bacha. Rishikesh, join in. There is a bar magnet suspended in a uniform magnetic field such that it experiences maximum torque. It's such an angle. Now, the angle by which you should rotate, so that the torque is half the maximum torque. The angle by which you should rotate so that you get half the maximum torque. Let's see how many of you get it. All right, Imia, you're in 10th standard. Bacha, this is too early for you. You can watch my nurture series probably from the beginning so that you get thorough understanding of all the concepts. Yeah. Ashkrish RC, yes, you're a little bit late, but you can still join. Go to mentee.com, Ashkrish, and enter the code. Yeah, enter the code 65134449. That's the way you can participate. All right. Okay. Yes, Harsh, tomorrow the paper discussion will happen somewhere from 1 to 1:30. If I get the questions early, we'll start at 1. If you get it late, 1:30. Okay. So it all depends. Yeah. How should we send the questions? Chirayu, you can send it to Shimon sir, because I will be managing other things also. But you can also send it to me via Instagram. Shreyas_Vedantu. That's my Instagram handle. Shimon sir will be looking at Instagram constantly. I might not be looking at Instagram. I have another way of gathering the questions, so I'll be concentrating there. But still, you can send it to me or Shimon sir. Okay, so 60 degrees is the correct answer. A lot of you interpreted the question in a wrong manner. I'll tell you what went wrong. See, the torque is maximum, and that will be mv sine 90 degrees. So this is the angle when the torque is maximum. Now when the torque is tau max, torque max by 2, that means it is mb sine theta. I don't know what theta is, but I know what tau max or the maximum torque is. It's mv sine 90 divided by 2. That's mb sine theta. From this, mb goes, sine theta is half, so theta is 60 degrees. So a lot of you thought the answer is what the hell did I do? Theta is 30 degrees. Yeah, so sine theta is half, so theta is 30 degrees. So you might have marked 30 degrees as the answer, but hold on, the question is the angle by which it must be rotated. It must be rotated. So think about it, from 90 to 30, it's extra 60 degrees rotation. So hence the answer is 60 degree. You made a mistake. You made a mistake out there. No, it's not cos, it's sine. Torque is m cross b, mb sine theta. Yep. No problem, Harsh. All the best. See you at 1:30 as well. How many of you made that mistake of marking 30 degrees? Many of you have made that mistake. Okay. Yes, Shiva, we will tell you which shift was hard. Just keep attending our classes. In one of the classes only, I'll mention that. Okay, don't worry. Okay. Yes. It's not work, it's torque, bacha. It's torque. Who said it is work? My God, who was that guy? It's not work, bacha. It is torque. It's torque. Be careful. The angle through which it must be rotated from this position so that it experiences half the maximum torque. You made a mistake. You thought it was torque. Yeah. Rajaraman, yes, BitSat lectures are coming next week. I mean, this week only, sorry. Okay, let's get going to the next one. I'll be uploading the daily schedule by tonight. Okay. Now listen to the question carefully. There is a magnet placed with the north pole facing north in the north-south direction. I'll repeat. There is a magnet which is placed with its north pole facing north in the north and south direction. In its map of magnetic field, where will you get a null point? Where will you get a null point? Vanakam Solanga. I told Vanakam, Virat Kohli. Okay. How much video for crash course? Faza, did not get what you are asking exactly. You can be more clear about it. Come on, four-wheeler. Please come on track. You have gone off track. Don't spam or else you will get timed out by the admin. Hello Tesha, welcome aboard. Hello Shruti, hello ABCD, hello, welcome aboard. Hello Harini, welcome. Guys, if you are late to the Menti quiz, go to menti.com. Use the code 65134449. That's the way you can participate. Hello Himateja. Come on guys, I'm waiting for all of you to join. If you're joined, please let me know. If you're not joined, that's bad. Come on, you have to go there. Hello Aryan. Hello Doraemon. Hint. Okay, you have to draw the diagram, that's all. The answer is on its equatorial line. A lot of you thought it was axial. Now I'll tell you how to solve this. See, first of all, okay, let me show the bar magnet. The bar magnet is like this. This is the north, this is the south, and this is north, east, west, and south. The north is pointing towards the north in the north-south direction. The north is pointing in the north-south direction. That's how it is. Now, the external field by the earth, remember, Earth's magnetic north is in the south. Earth's magnetic north is in the south. So the field lines will come from the south to the north. These are the Earth's field line. This is Earth's magnetic field. This is the Earth's magnetic field. How will the field due to the bar magnet look like? Well, it will come like this and go like that. It will come like this and it will go like that. Alright, so this is how the magnetic field will look like. It will come from the North Pole, correct? And it will go like this, and it will go like that. Isn't that right? This is how the magnetic field due to the bar magnet look like. Now, what is the meaning of null point? Null point means net field should be 0. Can you see there is a point where the field will cancel? Do you see that there is a point? Yes, up and down, over here and over here. The green field is going up, the blue field is going down. So this is the line. And what kind of line is this? This is axis, guys. This is the axis. This is the equator. So it is going to be on the equatorial line. Understood? Null means 0. It's a standard value, you should know. Null vector means 0 vector. That's it. Four-wheeler, why are you interested in any Kerala people from Hyderabad? Then the next question will be, any Hyderabadi people from Andaman Nicobar who speak in Malayalam. Then you will ask, any Delhi people in Honolulu who are from Bora Bora Islands and their ancestors speak in Tulu. Then you will ask, I don't know, what else? Please let me know. What kind of permutation combinations? Are you looking for some mixed breeding out here? I don't know. Please concentrate on the session, bacha. Okay, let's get going. Let's get going to the next question. Okay. Hello Devan Kumar. Hello bacha. Welcome aboard. Let's get going. There is a magnetic dipole. This is the 8th question. Bits versus NIT. Which one will I choose? Rajaram? I will answer all your interview questions if you put it up in the comment section. Right now, let me focus on the session. I'll break the flow or else. Okay. A magnetic dipole is free to rotate in uniform field. What orientation will you place the magnet with respect to the field so that the torque is maximum and so that the potential energy is maximum? A magnet is placed in external field. At what angle will you place to get maximum torque and maximum energy, potential energy? Let's get going to the next one. Versatile Moksha. My God, what a name. Versatile Moksha. My God, such crazy names. I'll give you Moksha of bits, and in this week, I'll be uploading the timetable tonight, maximum by tomorrow morning, and I'm going to conduct a BitSat mock test, I think on Thursday, if I'm not wrong. Love you too, Shwed BZ. Okay, come on, my warriors, figure this out. Concentrate on your Menti quiz screen. His bits, my God, look at this. Guys, where you find it's like Shreyas sir is here live. Let us ask all the interview questions because he usually responds to all the questions. That's why. Very good, very good. I like it. Rajput Villa. Wow. Hey, give me some villa. Rajput Villa. Done. Easy peasy. Very good. Yes, this everybody should have got. 49%. What are the rest of the people doing? Hey, come on, man. Torque is mb sine theta. So, when torque is maximum, sine theta is 1. Therefore, theta is 90. Simple. Similarly, when you are talking about potential energy, U is minus mb cos theta. If you want U to be maximum, cos theta should be minus 1. Why? Negative. Negative, be careful. Minus into minus plus. Minus into plus minus. So make the cos value negative to make this maximum. So theta should be 180 degrees. So hence 90 and 180. That is the answer. A lot of people would have made a mistake thinking cos is maximum when theta is 0. And they would have thought 90 and 0. Nah, that's not the correct answer. Be careful. Let's get going to the next one coming up on your screen. Thank you, Ashu Bacha. Love you too, Bacha Log. Okay, sir, do you know Rashmika Madan? Yes, Madanana. Yes, I know Rashmika Madanana, and Rashmika Madanana doesn't know me. Very sad. Okay. Yes, I'll show the leaderboard after every 5 questions. Let's get going to the next one. A current carrying rectangular coil is placed in uniform field. In which orientation the coil will not tend to rotate? I'll repeat. A current carrying rectangular coil is placed in a uniform field. In which orientation the coil will not tend to rotate? Okay, let's see how many of you get it. Hello Piyush, welcome aboard. Hi Marcus, welcome. Okay, Doraemon is correcting whether it is Mandana or Mandanana. Okay, thank you Harni. Alright, so guys, if you're joining in late, go to mentee.com. Still participate. You can still participate. Do not worry. Even if the previous questions are over, it's fun. Just participate. You'll love it. Even if you participate in the last question, I'll be really happy. Come on, do it. And if you're late, do not forget to hit the subscribe button so that next time you do not miss our notifications, and hit the like button so that our videos pop up on your feed of YouTube. Yes, Marcus, you can still join the Menti. Uday Shankar, you are in 11, but you can just mark the answers randomly. Tukka, A, B, C, D. Let's see how many tukkas come correctly. Okay, so let's see. That's 41% correct. Oh my God. Why would people mark this? I'll tell you why would people mark that. Achha. Yes, be careful. Current carrying loop will not rotate. Will not rotate means torque is 0. That means M cross B is 0. That means theta is 0. Okay, that means if you have that rectangular loop, the field should be like this and the area vector should be like this. Now you see the angle between them is 0. Don't you see area vector is always perpendicular to the area? That's how area vector is. So the magnetic field is not parallel, it is perpendicular to the plane of the coil. This is the plane, guys. This is the plane. You guys mistook it for area vector. Be careful, the plane of the coil is this one. This is the plane of the coil. Yes. Yeah. A lot of you got it as A. It's not parallel. Parallel means magnetic field is parallel means it is like this. This is B parallel to the plane. Look at that. This is B parallel to the plane. In this case, theta will be 90. In fact, torque will be maximum. So understand, realize your mistake, bacha. Achut, hold on, bacha, will ping. There are a lot of messages. There are 100 messages in my inbox. I'm clearing it one by one. If I reply to some message, I'll again get a reply, again have to reply to that. So it takes a lot of time. The inbox keeps on getting bigger day by day. I will reply. Don't worry, bacha. Okay. Thank you, Uday Shankar. Love you too, man. You are also from Karnataka right now. I am in Bangalore. Next question coming up on your screen. Question 10. After this, leaderboard will be shown. There is a place on earth where the vertical component is √3 times the horizontal component. The vertical component is √3 times the horizontal component. So the question is, what is the angle of dip at that place? Here comes the question on your screen. The questions will get difficult from now on. Let me tell you that. After these questions, the question will get a little bit difficult. Oh, Jules Court, nice. Nice to know that. Ashwini, I am very good. Welcome aboard. First of all, hit the subscribe button and like button so that you will get your next sessions popped up in your YouTube feed, and go to mentee.com and use the code and join in, participate with others. Oh my God, Achut, now don't ask me where I stay in Bangalore. It's a mystery. I stay on the streets. I stay in the Majestic bus stop. Very good. Kunj, Mumbai. Kasakai Barai. I am Mumbai. Alright, let's get going. Oh, beautiful. A lot of you got this correct. I'm proud of you. Super proud. Very good. This was an easy one. Before I show you the leaderboard and go to the next set of 10 questions. So, there are two components. This is BV. This is √3 times BH. This is BH. So, this is your B. This is your theta. Remember, tan theta is BV by BH. This is √3. So therefore, theta is 60 degrees. As simple as that. That's option A. Beautiful. As simple as that. Very, very easy. Great. That's it. Very good, Surya. You know me. Somebody had messaged me somewhere. I don't know where. In the chat box only. Sir, I saw you on the road, sir. I'm like, good. Somebody told that. Oh my God. Next time I'm going to wear and cover myself with some scarf or God knows what. Oops. I have to show you the leaderboard. Yeah. Thank you, Kunj. I'm going to wear shades. I'm going to wear a scarf like that or a monkey cap and wear a jacket. Nobody will identify myself. Okay. Chalo, let's see. Himanshu, my God, ye kya hai? What is this? Zup, 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 zup. IIT Bombay gaya. Vijay, Shreyas, very good. So many Shreyases. Naman, Adira, wow. Adira reminds me of some movie character. Kurinji, very fascinating name. Anu, Sai Capto, Rakesh and me, Penguin. Very good. Guys, let me tell you, like you have seen, the leaderboard keeps changing, so do not lose hope. And even if in the end your name does not come up in the leaderboard, remember, Shreyas sir still loves you. Okay, let's get going to the next question. Questions will slowly start getting difficult after this question. Okay. Fauzan, reply to a comment or just post up a comment in any video, recent video, I'll reply. Any recent video of mine, I'll reply. Not right now. Which of the following graphs correctly represents the variation of magnetic field with a distance r for a long wire which carries current? Which of the following graphs which of the following graphs correctly represents the variation of magnetic field with distance r for a long wire carrying current? Oh yes, KGF, Adira. Yeah, that's true. Adira, KGF, correct. When are you live? Kunj, I am live usually at 7:30 every day, but the timings can change. So that's why I said hit the subscribe button and there is a notification icon. Turn on that notification. Number 2, also follow us on Instagram because daily we on Telegram we keep on updating our schedule daily. Okay, so that's what you can do. Hyperbola, parabola, ebola, कौन बोला? Let's see what the answer is. कौन क्या बोला? अच्छा, सब लोग D बोला. Okay, correct. Oh, beautiful. Oh, and the correct answer is option D. And the reason for that is simple. See, when you have a long wire and you are at a distance r, it carries current I. The magnetic field formula is mu naught I by 2 pi r. Don't you see B is inversely proportional to R? So that's only one graph which is correct. It's inversely proportional to R. As simple as that. Excellent. That's it. It's not going to be proportional. Obviously this is not correct. It's inverse of a variable. So remember, when y is inversely proportional to x, the graph is like this. It's a hyperbola. What is it? It is a hyperbola. Remember that. Okay. This curve is called as a hyperbola. Okay. Let's get going to the next one coming up on your screen. Okay. Let's see. Here comes the question number 12. Now, on question 12, what you have? This is a big one, but do it properly. A bar magnet of pole strength small m and magnetic moment capital M. Pole strength small m, magnetic moment capital M is cut 5 times parallel to the axis. It's cut 5 times equally parallel to the axis. And then 4 times, it is cut 4 times perpendicular to the axis. What is the final small magnet that you will get? What is the new pole strength and magnetic moment of each piece? Yes, Ashwini Bacha, you can join the pro course. There is a link in the description box. Just go to the description box, you will see a link, pro subscription. Just click that link and just join. There are 3 packages. One is the light version, then there is a classic version and all that. So you can just check it out. If you still have doubts, just post a comment in the video itself after the video ends, or you can ping me on my Instagram handle, which is Shreyas_Vedantu. You can see that. Shreyas_Vedantu. You can ping me over there, you can ask me doubts. Alright. What code is that? This is the code to join the Menti quiz. You have to go there, participate. Everybody is participating in the Menti quiz using the code. Anuradha, you are not supposed to post any answers here. You have to go to the Menti quiz and post the answers, bacha. Vishwanath, What will you do using my salary, bacha? No use. Okay. Okay. Cool. Great, Ashwini. Glad to know that. Lemon squeezy, says Rajarangan. Okay. So, a lot of you answered it correctly. Many of you were able to visualize the divisions properly. I'll tell you what you should do. So, here is the thing. This is the magnet. North pole, south pole, magnetic poles plus M and minus M, magnetic dipole moment capital M. Now, when you divide it like this, okay, 5 times, each magnet that you will get, it will be M by 5 and minus M by 5 in pole value, pole strength value, but length will be L only. If the original length was L, it will be L only. Remember, this M is small m into L. Okay. Now what you are doing, you are dividing this into 4 parts or something. Yeah, 4 parts. So each of that magnet will be plus M by 5 minus M by 5, but this length will be L by 4. So the new magnetic moment will be M by 5 into L by 4. ML is capital M, 4 5s are 20. Hence, where is M by 20? M by 20 is everywhere, but you also want M by 5. So M by 5 and M by 20. That's the answer. Yep, that's it. Yep. No, sir, 10 lakh is too much, man. I get hardly what? 10,000 rupees per year. That's my salary. Okay, very sad. Come on, let's get going to the next question. Okay, and here it comes. Does the width or height of the magnet influence the pole strength? And yes, Nimit, like I just showed you. Okay. Yes, it will. Like I just showed you, if you cut it or if you have more magnets, it will definitely. And also the magnetic material will also influence. My God, Surya saw me near Lal Bagh. Correct, Surya, but when did you see it? That is also very interesting. Okay, so let's not discuss my salary. It's of no use, guys. Okay? I mean, what will you do with it? It's not like you are going to marry me now. Okay, chalo. Next question. A paramagnetic substance in the form of a cube. Look at the question. A paramagnetic substance, the 13th question, which is in the form of a cube with sides 1 centimeter, has a magnetic. Side is 1 centimeter. This is slightly difficult. Look at this. Magnetic dipole moment of that cube is 20 into 10 to the power minus 6. 20 into 10 to the power minus 6. The magnetic intensity applied on it. Is 60 into 10 to the power 3. What is the susceptibility? X. H is given and M is given. Sides are given. What is the magnetic susceptibility? That's the question. Badri, don't worry, you will be also popular one day and you will, you will just do this, and don't worry, you will also have a lot of girls around you, okay? But for now, you have a lot of books around you, so please concentrate on the books, bacha, okay? Chalo, let's get going. Paramagnetic substance in the form of a cube with side 1 centimeter has magnetic dipole moment so much and with magnetic intensity this much applied on it. What is the susceptibility? Very less time. No, it's very easy learning tricks. Come on, you are only saying, your name is saying easy learning tricks. Come on, you should be able to do this. Okay, chalo. Let's see how to do this. 3.3 into 10 to the power minus 4, guys. I think many of you did not remember what is the formula for that. See, what we need to do, susceptibility. I had told you, remember this formula, X is equal to I by H. XIH, remember this. And I is magnetic moment per unit volume. And therefore, now you just have to use all the given information. Magnetic moment is 20 into 10 to the power minus 6. Volume 1 centimeter into 1 centimeter into 1 centimeter. 1 cc. So volume will be 1 into 1 into 1, which is 1 centimeter cube. Centimeter cube is 10 to the power minus 6 meter cube, and H value, that's also given, 60 into 10 to the power 3. 10 to the power minus 6, 10 to the power minus 6 gone. Okay, you can see that. And this 0 gone, this 2 gone, and this will become 3. 1 by 3 into 10 to the power 3 will become 0.33 into 10 to the power minus 3. So where is it? Yep, 3.3 into 10 to the power minus 4. Yes, very good. I hope you guys got it. Very good, excellent day. Yes, so this is the way. It was not difficult. You should just use two formulas. X is I by H and I is M by V. So that was the formula which you need to remember, and just simple substitution you will get it. Okay, so I think we are on the 14th question now. Now 14th question is on a solenoid, and no Rishikesh, don't answer in the comments. You have to go here mentee.com and answer over there. Okay, yes. Jules Court, thank you for offering me that much salary. Tell me your office, I'm coming tomorrow. Okay, chalo. The magnetic field inside a long solenoid having n turns per unit length and carrying current I, when the core is kept inside it. It's not a normal solenoid. There is a solenoid, and inside that you have kept an iron core. Mu naught is permeability of vacuum, and X is the susceptibility. So what's the new magnetic field the moment you place an iron core? It will work, Saurav. It will work. No, I'm too old, Samuel, for Dragon Ball Z. I'm too old. That's the next generation cartoons. For me, it was Tom and Jerry, Scooby-Doo, and Popeye, and what else? SWAT Cats, Captain Planet, and all of that. Ganpati, there is no coupon code for micro courses. There is only coupon code for pro and crash courses. So if you buy pro, automatically micro courses become free. And the coupon code for pro is SHHPRO. All right. Okay, let's see how many of you have got the correct answer, guys. Let's see. Come on, my warriors. Saurav, bacha, don't answer here. Answer in the Menti quiz. Do not answer, or else the admin will time you out. 23 people have got the correct answer, and let's see. Come on, man. Okay. Yes. Now I'll tell you how to solve this question. See, what you need to do is, magnetic field inside a solenoid is mu Ni, but this mu is the permeability of the medium. Now what is the permeability of a medium? It is mu naught into mu r into Ni. Now you might be wondering, what is this mu r? It is the relative number. So mu r into mu naught will give you mu, the permeability of the medium. In fact, if you remember, there is a formula. Mu r is mu upon mu naught. So when you take this over here, you will see this exact relationship. Now there is another relationship which you should know. I hope you know that. Mu r is 1 plus x. So using that, what will you get? We'll get mu naught into 1 plus x into Ni. Alright, so guys, what's the answer? It's answer D. I hope this is clear. You just need to remember the formulas. Within 2 steps, you have got the answer. It's not a big problem. Yep, that's how it is. Manipali, just keep a track of our lectures. You will see when the next Menti is. I cannot tell you now, but it will happen after every big chapter is over or a big unit is over. We'll be doing Menti quizzes. Okay. Somebody is asking me to read his name. I'll read your name, but there are 4 people in your account. Whose name should I read? That's the problem. Okay, question 15 coming up on your screen. There is a proton, there is an electron. There is a proton, there is an electron, both moving with same velocity. They both enter a magnetic field, which is perpendicular to their motion. Okay. Now, once they go inside, they will go in circular orbits. The question is, whose time period will be more? Rishikesh, yes, Vedantu is for JEE, NEET both. This channel is exclusive for JEE, but even a NEET aspirant can watch it because physics and chemistry is same almost, little bit of higher difficulty. But yes, if you want a specific NEET course, then yes, there is pro subscription available for all the NEET aspirants as well. Okay. Vishwanath, I'm not sure which free crash course you're talking about. All the crash courses are paid, bacha. I mean, there is nothing like a free crash course. You have to go to any of our previous videos, just open the link and use my coupon code, SHCC. From that you will get 50% discount on the crash courses. So right now it is at 5,000 rupees. No, Shivam, don't answer here. Go and answer in the mentee.com. Even now you can participate. Eklavya is not a crash course. Exactly, Shiva. It's a proper course. So it's for advanced. Yeah, that is free provided you have more than 97 percentile and you have the right mindset. Yep. So that happens based on the interviews that we conduct. Yep. The time period for the proton will be higher. That's the answer. Few people got it. Few people did not. See, there is a formula for time period. Time period is 2 pi m by qb. So whenever you have a charged particle which is put in a magnetic field, okay, it will go in a circular path. The time period for that circular path is this. Now, because it's a proton, okay, Q and B are same. Q is same because value will be B because same magnetic field. 2 pi is also same. So all these are same. Only mass are different. Who has more mass? Proton. So obviously time period will be more. So hence time period for proton will be higher. As simple as that. Satvik, don't spam, but which coupon code are you asking? You need to tell me that. Okay, great. Let's see the leaderboard now. Guys, are you ready? Because after this, the leaderboard will be shown only in the last question where the final winner will be declared. Wow, look at this. What happened? What just happened? The entire leaderboard just got changed, guys, upside down. My God. Naman, the fastest. Enthuse Club. Very good. Rakesh, Kurinji, Shreyas, Himanshu, IIT Bombay, Sai Capto, Kiran, Anurag and Anu. Guys, really tough fight. Really tough fight, man. Come on. Don't worry. Fight it out. Guys, get battle ready. 5 more questions to go. 5 more questions to go. Let's get ready with the 16th question where there is a current which is being carried by a wire and there is another wire placed perpendicular to it. If that another wire is free to rotate, because of this wire's magnetic field, will that other wire be affected? And if it is affected, how? Will it translate? Will it rotate? Or nothing will happen? Here comes the next question. Come on, come on, come on. Suraj, every 2 weeks there is a new batch for 11th and 12th, both. So Suraj, if you are 11th, there will be a batch starting every 2 weeks. So you just join. Even if you have missed the latest batch, you will be automatically enrolled in the next batch. So you can attend all the live classes. Even when you have joined and even if your batches have not started, you can watch all other content for free like micro courses or any other courses that are running currently. Even the recorded sessions you can watch, so your time won't be wasted, and the subscription is valid till the end of the JEE Advance of whenever you have planned to take. Hello Shanmuga, hello Adarsh, hello Bhanu Prakash. Join in bacha log. Good evening, good evening. Come on, go to mentee.com and participate in the last few questions coming up on your screen right now. There is a current which is being carried in a wire which is placed perpendicular. Let's see how many of you get this. Okay, well, the answer is both, and I'll tell you why. See, because of this wire, right, the long wire CD, there will be a magnetic field around it like this. So the magnetic field will be very strong here and it will become weak. So it is strong, and as you go far away, it will become weak. Because of the magnetic field inside, there will be a force acting on it. Remember, force is IL cross B. Length, okay, is in the I cap direction. Magnetic field is in the minus k cap direction. You can do the cross product I cross k, okay, it will give you j cap. So this will be in the j cap direction. You will see there will be a force here, but since the field is strong, the force will be strong, and as you go far away, the field will become weak, force will also become weak. Hence, you see large force here, and small force over here. So what will happen because of these forces? Obviously, you can clearly see there will be a torque and there will be acceleration. So both will be there. Hence, there will be translation as well as rotation. As simple as that. Hello Manikanta, join in bacha log. Come on, join in. No Jules code, I have not done with my dinner. I'll only have my dinner after this Menti is over. I'm not even worried about the dinner. Alright, next question, question number 17, coming up on your screen. Alright. Tanu, all the best bacha. Do well and you're going to rock it. Okay, let's get going. Very good, Sujal. You have seen the revision session and glad it helped, and keep seeing you live. Hello Sudarshan, hello Sridhama, join in bacha. The next question is a total magnetic flux in a material which produces a pole strength of MP. Total magnetic flux which produces a pole strength of MP. When a magnetic material of cross-sectional area A is placed in a magnetic field strength of H will be. I'll tell you, flux is asked, pole strength is given, H is also given, A is also given. Somehow juggle between all the formulas and find out the flux. Answer will be in terms of mu naught, H, A and pole strength. Come on, let's see how many of you get it. You need to know all formulas. Come on my warriors, figure this out. Gauri Shankar, I'll explain the question when I discuss the solution. Hello Priyadarshan, hello Chintu, join in Bachalo. You have to go to mentee.com. That's an online way of participating in the quiz, and this quiz is being held internationally. So many participants from everywhere around the globe are here, and you can see your points and be in the live leaderboard, which is going to be shown in the last question now. Very good, Surya. Thank you, Marcus. Come on, my warriors, figure this out. I've given you more time because you need that time. Neeraj, don't post the answers here or else you'll get blocked. Hello Ram Lakshmi, hello Monu, Raja. Come on. No, you do not have two choices, two options, so you cannot mark it twice. You only get that chance once. Hello Kirti. Hello Shubha Ghate. Welcome aboard. Saurav, obviously always HC Verma first. Okay, let's see. The time is up. Ooh, look at that. Look at that. My God, 55% have got it correctly. And the time to see what is the way to solve this question. A lot of people might have got the answer maybe by Tukka also. Let's see. Flux is magnetic flux is B into A, correct? That's the value of flux. Now what will you do, guys? B is nothing but mu into H into A. Okay, this is the mu of the medium. Now that's the standard formula. In case you have forgotten which formula am I talking about, I'm using this formula. Mu is nothing but D by H. So using that, I have got this. Next, okay, mu is nothing but relative permeability and absolute permeability's product. So this into H into A. So where did I get this from? Because of this formula. Mu R is equal to mu by mu naught. Okay, next, what I will do? Mu naught into relative permeability is 1 plus X, standard formula. into H into A. How did I get this? Standard formula, guys. I mean, mu relative is also 1 plus zeta, susceptibility. Next up, what do we do? Okay, so how about taking it inside? So H plus XH. Now guys, do you know what is the value of XH? How many of you know the value of XH? No? Okay, let me tell you. See guys, X is I by H. So X into H. What will be X into H? Think about it. X into H will be I. So this into A. Yep, that's the value. I hope you guys understood. H into 1 is H. H into X is I. So that's the formula I have used over here. Okay, next, what else is there? Acha, mu naught, oops. Yeah, next will be mu naught into H. What is I? I is magnetic moment by volume into A. So that's the formula for I. That's the standard formula. I is M by V. Now, next formula, you will get mu naught H plus magnetic pole into length, and volume is area into length and into A. I hope you know this formula as well. Capital M is small m multiplied by L. Now LL gets cancelled, and what will you get, guys? What will you get? You will get mu naught, just multiply H plus small m by A into A. Correct? So do you see now what should be the answer? It will be nothing but mu naught into HA plus M. That's the answer. So if you know all the formulas, you will get it. Yep. That's it. Mukesh, by approximately October, I'll finish the 12th, and by approximately December or November, I'll finish the 11th standard portion. Okay, 11th standard portion, we have a lot of time because the batch only got promoted from 10th to 11th very late. So all the academic year has been shifted. For 12th standard portion, we roughly plan to cover it by October. Okay, by that time, it's a good time. Most of the institutes cover the entire portion around October only. Okay. So Rashi, why don't you put up comments after the video? I'll definitely help you out with which books you should refer to also. Okay. Thank you, Arshad Bacha. Now question number 18 coming up on your screen. There is a bar magnet of magnetic moment 100. You bend it. You take a bar magnet, bend it and convert it and bend it at an angle of 60 degrees. So bar magnet of 100, bend it at the center and make the angle between them as 60. What's the new magnetic moment? Let's see how many of you get this. It's very simple, just vectors. Oh, okay, no problem, Surya. Lalbagh metro station. I don't know how you saw me, but yeah, maybe long time back. John Paul Creations, all the best, bacha. Do well, sleep well, and be confident, and do not study anything which you don't know. Okay, all the best. Gyan Gigi, all fields are very good. Do not rush into computer science because people tell computer science and IT have very good field and scope. But then when people are, when a lot of people take up a branch, understand the crowding effect takes into effect because all the people are competing for the same thing. So you really need to stand out of the crowd to actually perform really better. Yep. Ankit, this is an English channel, bacha. So there is a separate Hindi channel as well for all the Hindi speaking students. It's called Vedantu JEE. So you can watch all the lectures out there as well. So for all the English medium students, we have this special English medium channel. Thank you, Roshan bacha. Kanan, how about posting up as a comment so that even others can benefit from your doubt? Okay. Let's see how many of you have got the question correctly. Come on, quickly. Hey, Kirti is my new minion. Thank you, Kirti. Thank you so much. Okay, let's get going. Hardly few seconds remaining and the time is up. Trimbak, all the best. Okay, and a lot of you got the wrong answer. Only 21% have answered it correctly. Now I'll tell you how to solve this. See, the bar magnet was like this. Okay, this was north pole, this was south pole. Okay, the magnetic moment was 50, correct? Oh, sorry, 100, my bad. So it was 100. Okay, this you can treat it like this is 50 and this is 50, exactly at the midpoint. South, north, south, north. It's like two magnets. Now you bend it. Now it will be easier. So you have bent it at the center, something like this, I believe. Okay, so this is south, north, south, north. So this is 50 this way and this is 50 this way. Okay, so you have bent it and this angle is 60 degrees. Now, if this angle is 60 degrees, how about adding these two vectors? Now, in order to add these two vectors, think about it this way. There is one vector like this which is 50. There is another vector like this which is 50. This angle is 60. Now, in order to add this, guys, use just simple logic, brain. This is an equilateral triangle. This is the resultant. Isn't this the resultant, guys? You don't need formula. So obviously the resultant should also be 50. Hence the answer is 50 ampere meter square. As simple as that. You don't have to find the other angle. 50-50, it's an isosceles. In an isosceles, if the topmost angle is 60, what will it become? Equilateral, right? So that's it. The resultant is also 50. As simple as that. Good evening, Siva. Okay, is that clear? Everyone understood? Clear? It's very easy. You don't have to use any formulas. That's the best part, guys. Okay, let's get going to the second last question. I will tell you what the question is. Saurav, nobody knows what the cutoff will be, bacha. Kanu Kirtana, all the best. Love you and do well. All the best. The pole strength of a 12 centimeter. Pole strength of a 12 centimeter long bar magnet is 20 ampere meter. Pole strength of a 12 centimeter long bar magnet is 20 ampere meter. The magnetic induction at a point 10 centimeter away from the center. You will get 2 minutes for this. Draw the diagram. Trust me on this. The pole strength is 20 ampere meter. The length is 12 centimeters. The magnetic induction on the axis at 10 centimeters from the center is how much? Let's see how many of you get it. Ishani Bacha, I'm very good. I hope you are doing great and please join the Menti quiz at least for the last 2 questions. And if you are a new user to this channel, welcome to the JEE English channel and hit the subscribe button and do not forget to hit the like button. Tomorrow afternoon, Sai Telugu. Please do well, Sai Telugu. Musical evening. I hope you really have a good evening tomorrow. Yep, all the best, bacha. Ishani, I'm not sure where are you facing problem, bacha. Have you read the chapter of magnetism? Have you attended my classes of magnetism? Please read or probably watch the lectures of my previous magnetism session. Yep, come on. Okay, come on, my warriors, figure this out. The pole strength is 12 centimeters. Pole strength is 20 ampere meter, length is 12 at 10 centimeters from the center. What do you think is the magnetic field? Bomavaran Venkata Sainath Reddy. I am very good. Okay, your name is longer than your comment. Jebasteen Jeba, you're late, but don't worry. Please hit the subscribe and the bell icon so that next time you do not miss my class. 24 something. What is this 24 something? No, Siva, the percentiles are calculated relatively, so it's not unfair. Don't worry. Okay, come on, let's do this. Ishani, it's very difficult to explain again everything. I would advise you to join the micro courses on Vedantu Pro subscription or watch the lectures in the repeat mode. And if you still have doubts, please ask the doubts in our doubt app. Okay, that will be very good. Okay, trust me on this. You just need to have patience and study it in a proper way. You can leave a comment after the video. I'll reply to your comments. Okay, a lot of people got the answer, but a lot of people made a mistake. Now let me tell you what is the problem in this. See, when you draw the magnet, everything will be clear. There is a minus M pole, there is a plus M pole. Okay, what is the separation between them? The separation between them is 12 centimeters. From the center, you are at a distance of 10 centimeters. The question is, what is the magnetic field here? You cannot use the axial formula. If you have used it, wrong. Remember, the axial formula is applicable only when distances are large compared to the length. Here you cannot use formula. So don't use axial formula. In my live classes also, I made you do one question where axial or equatorial formula was not applicable. So because of plus M, the magnetic field will be here because of the plus wala field, and because of the negative, understand the field will be here. And notice one more thing, this distance from here to here, okay, this is 12. So this is from the center, this is 6, right? So this will be nothing but 4 centimeters, okay, and this distance will be 6 plus 10. This is 10, this is 6, half of 12 is 6. So this will be 16 centimeters. Now you can do this. Now what you need to do, you have to substitute the formula B plus and B minus. So what's the general formula for B? B's general formula is mu naught pole strength by 4 pi r square. It's just like 1 upon 4 pi epsilon naught q by r square, same formula. So guys, what will you get the net field as? Bigger field minus smaller field. B plus, this is minus, sorry. This is B plus minus B minus. They will cancel partially. Is that clear? Understood? Everybody understood? Let me know if you guys understood what we have done. This is 12, this is 6, this is 6. This is 10. If this is 10, this much will be 10 minus 6, which is 4. And this much will be 10 plus 6, which is 16 centimeters. Cool. Now, the field over here, due to positive will be this way, due to negative will be that way. So, the subtraction of the two. So, what will be the subtraction? B plus and B minus. Lot of things will be common. Mu naught M by 4 pi. And here you will have 1 by R1 square minus 1 by R2 square. That's it. So, when you do the math, what will you get? Okay, what will you get? Mu naught by 4 pi is 10 to the power minus 7. Small m is given 20. And what else is there? This one. This will be 1 by distance is 4 square and this is 16 square. But this is in centimeter. So I'll multiply by 10 to the power minus 4 to convert into meter. Now solve this. I think you should get the answer as A. Yep. Is that clear? Are you guys ready for the last question? There is no shortcut, believer Venki. Hello Ramesh, welcome aboard. So this is the way to solve it. The critical aspect was you cannot use axial formula because 10 is comparable to 12. If this was 100 meter, yes, you can use the axial and equatorial formula. Already specific see why I have done acceleration, velocity and time in my nurture series. Just check the playlist, bacha. You will find it. Kinematics in 1D. You will find it. Also in the bridge course I have explained about it. Okay. Last question. Get ready. Last question. Best question. It's not difficult, but there is a small catch. If you do it correctly, that's it. Okay. Now, an electron gun is placed along a long solenoid of radius r. The gun is placed on the axis. There is a solenoid of radius r. On the axis of the solenoid, you have placed the gun. The question is, if the solenoid has n turns per length and the current is I, and the gun shoots an electron along the radius, and with the speed v, such that the electron does not hit any of the surfaces of the solenoid, then what's the maximum possible speed with which you throw it? Because remember, solenoid will produce field, the gun will shoot the electron, it should not touch any of the sides. With what maximum speed can you shoot it along the radius? Remember, the gun is on the axis. Specific psi, you can just find it, bacha. Just go to the playlist tab. I'm pretty sure you know how to use YouTube videos, playlist, about, all those tabs are there. Just see that. Believer Venki, induced EMF. I'll be doing it this week onwards. I'm starting in Pathfinder EMI, but if you want to see my previous classes in Flash series, you are free to do so. It's also there in the playlist. Amrita Raj, last attempt. Yes, Amrita, the what is it? Rank booster series will continue. Amrita, what will happen is this week we'll do a lot of BitSat, and next week also BitSat related tests and mock test discussions and all of that. After that, rank booster, you will have on and off classes. Yep. Shalini, there is no use of one-shot classes right now. One-shot classes have use at the end moment. If somebody has told you study from one shot, it's waste. Please understand. How can you understand an entire chapter of magnetism in one shot? People fool a lot of students by conducting one-shot classes right now. See, there is a time for one shot. When you have not studied anything and it's, exam is close by, that's when you conduct one shot. This is not the time, bacha. Yeah, please watch regular long-term batch sessions in Pathfinder or Nurture series. Rishikesh, all my lectures from electrostatics are there in detail. You can watch the replays of all the lectures. Electrostatics, Gauss's law, current, electricity, everything is there. Just check it out. It's there. Okay. Okay. Yes, correct, Shiva Ganesh. Yes, Rama. See guys, one thing special about our channel, is we do not do something which is like false, or we do not do fake promises, because I don't want to show something which will never benefit you. I might get views, I might get a lot of popularity by doing one-shot videos, but I will not do that, because right now what is essential for you guys is basically the long-term batch, and that's what I'm doing. Towards the end, yes, did you not see in my Flash series I conducted in a crisp manner, and did you not see in my Zero to Hero series, they were one-shot videos only because the timing demanded that. So in that one shot, it was designed specifically for those students who have some idea. Else you can never learn, bacha. Yep, correct. Zero to Hero was one shot for all the students who knew it from, who had some idea at least from before. Okay, 42% correctly. Now let me tell you how to solve this. Okay, quickly, let's go to the solution. See guys, this is the cross section of the solenoid. This is how the magnetic field is inside the solenoid. What's the field formula? Field formula is mu naught Ni. Now, when you are at the center and project something along the radius, what will it do? It will go in a circular path like this. This is the path which is a circle. Oops, this is a path, and it will perform uniform circular motion. So guys, tell me one thing. What is the radius of this circle? Isn't the radius of this circle the radius of the solenoid's half value? So isn't it half of that? I hope you guys saw that. Yep. And this radius is also given by mv by qb, correct? So how about shifting it there? So what will you get from this? V is equal to r by 2, and qb will be on the top and m will be below. So I'll get r by 2m. Instead of q, you will have charge value, and instead of b, you will have mu naught Ni. So that 2 is very important. A lot of people would have missed that 2. That's how it is. How many of you made that mistake? C and D are same, but anyways both are wrong. They might be same, but both are wrong, Karthikeyan. Okay. Okay, that's how it is. I hope this is clear. Okay, very good, very good. Time to see the final Menti quiz winner. Time to see the final Menti quiz winner and in the leaderboard. Electricity specified, that's done. You can check out the playlist. It's all there. Okay. Who is going to be the winner? हिमांशु क्या IIT बॉम्बे जाएगा? जरूर जाएगा, definitely. Very good, congratulations. 12,656 points. V Enthuse fan club, excelente. Kurunji, Naman, Kamila, somebody Kumar Das, and Har Presha, I think Shreyas, Anurag, and Sai Capto. Congratulations everyone, excellent. You have performed very well, and do not worry even if your name was not there on the leaderboard. This was so much fun. I'm glad you guys have enjoyed it, and to show your love and support, please hit the like button and the subscribe button. If you want to join our batches, there is a link in the description box. It says Vedantu Pro subscription, 10% off using my code. And what's the code? SHHPRO. Live classes, doubt solving, assignments, micro courses, you name it. Even KVPY course, everything is there. And if you have forgotten to watch my KVPY strategy session, which I conducted at 3 o'clock, please do watch it. And see you guys tomorrow for Nurture series. I'll be posting all the updates on our Telegram channel. Join the link which is there in the description box below. And keep an eye, close eye in fact, on our channel, because our videos get posted regularly and very often, and BitSat series also continuing. Tomorrow we will have a paper discussion in the afternoon and evening, Nurture series for the 11th standard kids. Bye bye. Thank you so much. Hasta la vista. This was Shreyas here, and I was going live from Bangalore.